Is it in presentation mode?
Yes, I believe so.
Okay, very good. Thank you. Okay, guys, so this is a lot of experience here. So we have 3 sections. So we're trying to, this is the first time we are doing, one is the fully online, which is called asynchronous mode or PNAPTO. And then we have a Zoom section, and then we have in-person section. So I'm trying to figure it out, so just please be patient. Okay, so this is the Advanced Computer Vision course, CIP 6412, and my name is Mubarak Shah, and this is my email. So please try to contact me through this email, not the Canvas, and web course is easier for me. And so my office is upstairs, HEC 245, and Savitha will be the GTA. She's out this week, but she will be back on Friday. And so, as you know, the class is Mondays, Wednesday, 3 to 4:15. And so, as I said, there are 3 sections. One is here in 103, then Zoom and PNAPTO. So this is a link for the Zoom section, and the office hours are Mondays 2 to 3, Wednesday 4:15 to 5, which would be after the class, and then Friday 1 to 2 p.m. and by appointment. And we'll have office hours for the GTA also. So this class requires prerequisite 5415. So if you haven't taken, so please, withdraw the class. You won't be able to take it if you haven't taken the prerequisite, okay? Because this advanced computer vision class, we want to make sure that you have the basic background. But if you have taken, say, CIP 6411 computer vision system, then it's fine. So you can stay. But if you haven't taken either one of those, then you have to withdraw. Okay, so I'll make sure that you withdraw. Otherwise, you'll have trouble. So, so we have this course website. So most of the information I'll put on that website, and pretty lot of details. And we have I can actually go now, and hopefully I'll be able to come back. So this is a website, and then this is the schedule. We will populate this more, and these are the research papers we will discuss. So now I should go back to the thing here. Okay. How do I go back to my PowerPoint? Okay, let's see here. Okay. So it's still visible? Are people, okay. So course objectives that you want to expose you to to visual language models, as you guys have been hearing, using ChatGPT. So visual language model is more than that. We'll talk about that, where the input can be image, video, and audio and so on. And ChatGPT input is image, and input is text, and output is text. And then we'll talk about diffusion model. And you must have seen that you can generate lots of very realistic looking images, synthetic images or videos. So we'll talk about that also. So those 2 models, and these are called generative models. And then, since these models are being used in the real life, it's actually making a lot of difference. So it's impacting society. So now we have to address these issues related to bias, privacy, trust, toxicity, and lots of these things. That they are fair, they are legal, and all kinds of issues. And that's big research area now. So the learning outcome will be that you, at the end of the course, you should be knowledgeable in visual language models. These are called also VLM, and diffusion models. And also you should be able to read and understand research paper. So the way I've structured this course. The first half, roughly, of this course, I'll give lectures on these both VLM and diffusion models, and then other half of the course we'll discuss recent research papers. So, so there you will learn how to read a research paper, because this is mostly for graduate students, in particular PhD students. There's an art of reading a research paper, and then how you can write a comprehensive review of the paper and identify strong and weak points of the paper, and then prepare a detailed presentation about the paper and deliver in the class. So we'll make groups of 4 to 5 students. Right now we have 66 students altogether. We'll see how many stay. So each group of students will pick a paper. The list I show you will update that, and then understand the paper. Meet with me, prepare a presentation. I will review the slides, and then we'll do a rehearsal. After review slides, I'll give comments how to improve, and then we'll have rehearsal. You will go through the presentation, then we'll come in the class. We'll make a presentation, we'll record, we'll put those presentations on the YouTube. So we have a very popular CRCV YouTube channel. We have more than 25,000 subscribers. So all these presentations actually being watched, lots of people all over the world. And we get lots of views. So this is one way you will get a lot of the visibility if you want to look for a job and so on, if you do a good job. So then after you read paper, present, and so on, so the main thing is this is course is about how to do research and how to come up with new ideas. Say you read a paper on particular problem, so main thing as researcher, you want to ask yourself, this problem, how I will solve it, okay? Because researcher, you read a paper, understands fine, but that's not enough. So you have to do your own research, which means you have to say, well, okay, this is a solution for this problem in this paper, but can I do better? What are the weaknesses of the particular approach, and then generate new ideas, and then you will ultimately you want to write a research paper. So the project we will have the final outcome of paper will be you will submit a research paper, final presentation, and the paper you will learn how to format a paper using LaTeX and so on. All these are good practice, like you're submitting paper to CVPR and so on. And also you will work on a research project, so the paper report will be on that. So the grading will be that we will have the several assignments, which will give you experience about these VLM and diffusion models. I'll talk more about that. And then presentation will be 10% of the paper your group will select, and the reports about. So each of the paper you will present will be one, but there'll be other groups will present. So for each of the paper you will write a report. Okay. So I'll give you practice how to read a paper, understand, and write one-page report. And the projects will be 35%. Okay. So now in the past we have complaints that in a group of say 4 or 5 students, maybe 1 or 2 students will do the work, but other students will not, and they say it's not fair. So what we have been doing, that all the members of the group will give the grade out of 100 to other members. So we will average those, and we will scale the grade. You will get a grade for the whole group, but your points will be scaled depending on the other groups of members, how how they feel that how much you contributed. So it's kind of balances out. So there's no midterm, no final, no homework. I mean, of course, assignment. So let policy 0 for the reports and presentation, because after we discuss a paper, then there's no point of submitting the report, because main thing is I want you to read paper yourself, try to understand, learn this capability that you, as a researcher, you'll take any paper, try to understand, you'll learn this thing. Okay, so then other thing about 20% off per day. So the project will be that there'll be 3 in-class presentation. The first will be that you will present a project idea, what project you want to work on. Of course, it'll be in this VLM and diffusion model. And then there'll be update 1, then update 2, and the final presentation. So assignments will be using Google Colab, and so that everybody can get account yourself. And I mean, you're free to use your own desktop if you have, but we have found out that UCF doesn't have enough resources for the courses, and it's a lot of complications. So Google Colab is, I think, the latest thing we'll follow. And some of these students, actually, you can pay. Mostly Google Colab, to a certain extent, is free. But if you want more capacity, then I think you can pay minimum amount. You're welcome to do that. Or any other AWS or anything on your own. PyTorch will be used. This is the link for that. And also Hugging Face has lots of these information. Notebook, there's a link for that. Okay, so the report will be, we'll discuss 1 paper in each class after my lectures. First half, we will just have lectures. Second half, we'll discuss papers. And so you will select the paper you want to do, your group want to do. So first is you start making your group, okay? So you'll have enough time to make a group and try to work with students you really, know and will work hard, because in the past we have experienced, students, they fight among group and we have problem to deal with. So be careful how you select your group members. So you will select as a group the paper you want to do from the list, and then we'll fix a schedule when you will present the paper, and then for the rest of the people, they will read the paper before the class, write a 1-page report, and submit before the class. One group of students will make presentation, and all the students will participate. So the presentation is about 30 minutes, but then we'll discuss. Okay, so you can select the paper you want to present from the list, of course, from the course website, and reports will be due just before the class schedule. Okay, and this is the schedule as I showed you the course website. So report will be 1 page and should contain these parts. Very short summary, in your own words. Okay. Good points, what you like about the paper. Weak points, which you don't like about the paper, and what questions you have, because these research papers, they have lots of work have put in, so you'll have many things probably you don't understand. So, and then what are your ideas? How you will solve that problem. These reports will be not graded. This is an honor system, and by submitting report, you will pledge that you have read the paper, okay, have written report yourself, have not copied word by word from the paper or from any other students or leverage resources like ChatGPT and so on. Okay? So this is a golden rule. We'll follow this. Plagiarism and cheating of any kind on examination, quiz, or assignment will result at least in F. And for the assignment or maybe for a whole course, and we may refer you to Office of Student Conduct for further action. And I'll assume this for this course that you will adhere to the academic creed of UCF, maintain the highest standards of academic integrity. In other words, you don't cheat by giving answer to others or taking them from anyone else. I will also adhere to the highest standard of academic integrity. So please don't ask me to change or expect me to change your grade legitimately, illegitimately, or to be bend or break rules for one person that will not apply to everyone. Okay, this is the way we will live. Okay, so so as I said, that this is schedule will follow. So if the paper is going to be present Monday, then you will, we'll do slide review of your presentation on Wednesday, a week before. Then rehearsal will be on Friday, week before, and then you'll come present on Monday. And for Wednesday, similarly, week before Friday, you'll slide review, and then rehearsal on Monday, that same week, and presentation on Wednesday. So it's all a structure. I've done this many, many years, so we have really improved the process. So let me give you an idea what the research paper is. So research paper has the following parts: the title, the abstract, introduction, and the rest of the paper. And all these, each of those four parts is equally important, which means you should spend 1/4 of the time thinking about what should be the title of your paper. Because when you publish a paper, people look at the title, and title is confusing, very general. People don't know, they're not going to read it. Then if they read the title, next thing they're going to do is read the abstract. So again, abstract is very, very important. So they will read the abstract, and abstract is confusing, not clear, just, general things. They say, well, why should I waste my time? Once they read the abstract, they say, good. Then they will read the introduction. That's also very important. Then the rest of the paper. Even though rest of the paper requires a lot of work, but rest of the paper will have related work section, method, what is your approach, results, and conclusion. But this is the formula of writing a paper which will have impact, and you get a lot of citations. Okay? So let me tell you a little bit about how to read a research paper, as many of you may not have read paper before. And we will learn how to read a paper, understand, do research, and come up with new ideas. So first is, this is not a newspaper, right? It's not something novel. It's a research paper. So first is you have to read research paper many times. It's impossible to read just once and you understand everything. When you read the first time, if you don't understand something, do not get stuck. Okay? Keep reading, assuming you will figure it out later. So you have to do many, many iterations. When you will do it second time, you will answer much more, and third time even more, and so on. Okay? So read the abstract first. And the way I do it, after reading abstract, I look at the figures and the captions and tables and get an idea, before reading the text. So the main tip is that when you want to read a paper, try to get a general idea. Say, well, this paper solves some problem, and what's the problem, right? And what's problem solved? What are the main steps? Because this is a computer science paper, there'll be different things, do this, do that, algorithm. So you want to identify those steps. And then all these things we have to implement, right? We have to have code which will be applied to the images, videos, and you show the results. So I'll always think about, say, well, okay, how will I write a code to do that? That will help you a lot. So even though I don't understand why each step is performed, but look at mechanisms. Say, well, do this first, do this second, third, fourth. That will help you a lot. Then always try to relate what you already know. Because the science is you build upon the concepts, right? Because you cannot memorize. It's an understanding. So once you understand, you will never forget. So you know something, now this on the top of it, you keep improving your knowledge. You find similarities, differences, what you know, that will help you. Okay, so in the first reading, it may be good to skip related work. Because you just want to know what's the problem, what's the method. Just don't worry about related work. And never use dictionary to try to understand paper, okay? These are concepts. These are very complex concepts. They are not defined in dictionary. I mean, you can do search on Google. You will find some useful information, but don't look at dictionary. Maybe these days, don't worry, look at dictionary. You can just go to Google, even for dictionary. So other thing is maybe try to understand each concept in isolation, then try to link them. That helps. So there are lots of useful blogs to how to read a paper, and these are some of those. So you can look at those. Okay, so far, any questions, anything about the course? Yeah.
So you mentioned, so for reports, you have to do it for every single presentation, and so do it for our own presentation?
No, you won't do for yours.
Okay, and is the reports individual or are they?
Individual. Okay, yes.
And for the assignments, the free version of Colab would be enough, like the scale and everything, like data sets and all.
Which version?
I mean, do we have to buy Colab Pro?
No, you don't have to. I mean, if you want, you can buy, but it's not necessary.
Yeah, because like the free version comes with like some limited compute, so
Yeah.
I'm just wondering.
Yeah, I mean, it's up to you. I mean, I won't pay for you if you buy. Yes.
For the slide review and rehearsal, my mom has the car on Fridays and she needs it. Would you be able to do it over Zoom?
Yeah, that's fine.
Okay.
Zoom, you can do Zoom.
Yeah, because I only have it on Mondays and
Mm-hmm.
Wednesdays.
That's fine. Yeah.
One more thing. The assignments are individual, right? The assignments themselves are individual?
Yeah, individual, yes. Mm-hmm. Okay, any question from the Zoom? Please unmute and start talking.
Yes, Professor. For the grading, I see like 45% on assignments
Uh-huh.
and 10% on presentation. Is this presentation for the final project?
No, the presentation is about the paper. See, as I said, that each group will present one paper, so that's 10% on that. The slide review, rehearsal, and presentation. Okay?
Same for the report, 10%?
Yeah, report 10%. Yes, that's separate.
Is it the report for the project or the report for the...
Report for the papers.
Okay. How many papers we should do during the semester?
All the papers you'll do, so I think we'll do roughly 10, 12.
And per group?
Group, you will do one paper, the presentation.
Yeah.
Okay?
There are also some questions in the chat.
Yeah, so let's do that. So how do I go to chat? Zoom here? No.
I can ask the questions if you'd like.
Yeah, please go ahead. Yeah, that'll be helpful.
One of the questions was, how does the online section differ from the live stream?
Yeah. Okay, so that's a good question. So see, the online section is, so we are doing this as a, the experience, because we are going to start a Master of Science in Computer Vision online, fully online degree in the fall. So we are doing to just get an experience as a pilot project. So online section will be, first they don't have to attend in person or on the Zoom. And after the end of lecture, so we will put the video of this lecture and you guys will be able to access that. And you are welcome to join the office hours, or if it's fully online, then you can send the presentation, then I will send comments, and then for the rehearsal, if you don't want to attend, then you will record a video of your rehearsal, presentation, then I'll send comments and so on. So we are trying to figure it out, that's what we are going to do. As we go through the course, then we will learn more. Did I answer your question? Hello?
He said yes.
Okay.
There's two more questions.
Yes, please, go ahead, yeah.
Will we be given access to the Newton cluster or another GPU option?
Yeah, so as I said, we used to do the Newton cluster, but we realize it's pretty hectic. First, there are not enough GPUs, and most of them are busy. People complain. So you are going to use the Google Colab. So you will have your own control, and Google Colab is free. You can use that. So no Newton cluster. And you are welcome to use your own desktop if you have GPUs. That's possible. Okay?
And then this final question, I guess, is like a joint one. So he asks about the attendance policy and also can anyone join the online section of the course?
Yeah, anybody can join. You are welcome to join. Attendance, we used to have attendance. It will take 10 minutes every lecture, so we are not going to do attendance. You are here, you are paying tuition to learn. If you want to learn, I'm happy to help. But if you skip classes, we have ways to determine. Yeah, so there's no requirement for attendance. Okay? Any other question?
I think those were all
Okay.
the questions. I don't see any others.
One more question, Professor.
Yes.
For forming a group, I see in the web courses, I only see the groups in my section, the online section. But is it possible to form a group from online section students and from in class as well?
Yeah, so I think that Zoom and in person is fine to have a group. You can have some student from the in person, some student from Zoom, but for online, we will not, allow that because we want to learn how the online, students work in a group. So online should do online. Group should be of all online students. Okay?
Still confused, Professor.
Hmm?
I'm 0V61 section. Is that considered as Zoom or online?
6.1 is the Zoom. 99 is the online, I think. Yeah.
Yeah, thank you.
Okay. There was some other question here. Yes.
Yes, I was asking, not even for the project, we can ask for Newton access.
No, I think we found out it's not useful. Probably it's hectic because see the problem with the Newton, you have to have a tutorial and there's arrangements and GPU is not available, and so it's better just do collab. Yes.
Are we allowed to explore other research papers, or do we have to stick with the list that's provided on the course website?
Yeah, I mean you can suggest if there are papers in this area of VLM, diffusion model, privacy, and bias and so on. You can suggest. We'll keep adding more papers also. Yeah. Yes.
When do we get to choose our groups?
Hmm?
When should we choose our
Right now. Okay? Yeah, because that's an important thing. And I think it's a very good experience, right? So because after you graduate, you will work in a company or where you will work with people. And we found out very surprisingly, many people have a lot of difficulties. I mean, there were fights, I have seen members of group, they fight and pretty scary. So just find, build a network. Yeah.
How many people in a group?
Yeah, so I think it'll be 4 or 5. So we will have 10 groups, roughly. We'll see how many survives, how many people not survive. I mean, how many people drop out if they haven't taken the prerequisite. So, yeah. Good, you have question?
Yeah, I was gonna ask, like for patients, it's like do we just do one, right? So like I saw there's a limit that for every week there's a paper. So like if there's not enough groups, does one group do 2 presentations? Or something?
Yeah, we'll see.
Okay.
Yes.
So you can pick other papers, but they have to be either VLM or
Diffusion
or,
model. Diffusion model.
Okay.
Yeah, bias. But you have to show me first.
Yes, of course.
I will approve then, yes.
The presentation, class presentation, will that be uploaded to Canvas?
Hmm?
The presentation that you just gave.
Yeah.
The links and all that.
Yeah, we'll put on the course website. So actually, let me show you. So I think we have a very good history of this course. So here. Okay, so this one is, let's see. So if you go to this CRC website, so this one we did last year, right? So it says everything. So this is a video presentation we put, the PDF we'll put, and these videos will be on YouTube. So we have YouTube channel, you'll get views, everything will be there, yeah. Okay, that's it. Okay, so let me now go back to the PowerPoint. So all the online people, I'm not good in following the chat. So please unmute anytime and ask questions. Okay, so we'll go back. I'll give you a short introduction of the visual language models. So some of this material, we have a very nice survey paper, which is actually accepted in PEMI also. You can look at that, and then there are several other resources also. So and this is about this diffusion model. We have also survey paper, this was PEMI, and lots of other resources. So you'll get these copies. So now if you look at computer vision, so most of you have taken the computer vision class, is that 5415. So in that one, we deal with given an image, we can classify an image, right? We can do object classification, we can detect object, put a bounding box, we can do segmentation, pixel-wise segmentation, we can do instant segmentation if there are two, say airplanes, one airplane will be a black, other airplane will be red, we can count the instances, how many type of that particular class appear. We can do retrieval, retrieve particular object based on the text. We can do semantic segmentation. We can assign each pixel a label, say this pixel is sky, a building, road, and airplane, or whatever. So now in video, we can classify what's action video. We can do tracking from frame to frame, and so on. These are the standard computer vision tasks. Now, the limitation of these tasks is that they only provide the output in terms of the bounding boxes, classes, and so on, right? So now they don't communicate through text, but humans are good in language, right? So, so language and text is important. And for example, if you have the images, given an image, you want to caption the image, what is the image showing? You can, given an image, you can ask questions and get answers. And given an image, you can retrieve the corresponding text, made to text retrieval, or given a text, you can retrieve an image. And you can do text-guided image generation, the diffusion model. You can have prompt and generate particular image or a video. So, yeah, similar things for video captioning, video question answering, video text retrieval, and so on. So, for example, these are the captioning examples, right? So, we want to come up with automatically the caption for this image using computer program, and so on. Then, given an image, we want to, ask question and get answer. So these are the examples for that. Then, given a text, we want to retrieve a video, the text video retrieval, and more examples. Okay. So the natural language processing you have been using in search engine, spam filtering, machine translation, sentiment analysis, NLP. There's a whole course about NLP, as you guys know. Document summarization, and so on. So limitation of the traditional natural language processing is that they are not able to decode visual cues, and there are some linguistic ambiguities in verifying interpretation against real-world visual references. So the language models, understand and generate a text, and they learn from the raw text. Okay, so transformer architecture is the big breakthrough, as you guys know. The GPT is the generative pre-trained transformer, and the large language model, they are pre-trained on large data sets. Okay, they have large number of parameters, billions of parameters, and So because there's so much text available, so LLM data set. So first thing, some of these slides are from last year, and you will realize in just 1 year, things are moving so fast. There's so much going on. So first thing is, I think you guys should be very happy to be taking this course, because this is the what is the future, right? The AI is the future. It's going to impact everything. Okay, you heard 2 Nobel Prizes were awarded in AI this year, so it's going to impact everything, and this is what is happening in everywhere, right? There's so much excitement in the AI, especially large language model, visual language model, diffusion model, generative AI. Billions of startups are starting, and a lot of excitement that you can do so many things. So this was from last year, that LLM data set are 60%, they crawl the web and get training data. There's web to text, OpenAI uses from Reddit, then Books 1, Books 2, and Wikipedia, all the text being digested in these models. So LLMs, these very initial LLMs were Lambda, developed by Google. This was trained on 1.56 billion words. And then Llama from Meta, the initial version of Llama, 7 billion. Bloom, Galactica, Codex, Palm-E from Google, and all those things. So this is a more recent, as you know, that now these models, these are also called, instead of LLM is large language models. These are called LMM, large multimodal models, right? So language is one, text is one. Other modalities are the images, the video, the music, and all those other things. So GPT was GPT different versions, GPT 1, 2, 3, 4, and all those things. Gemini from Google also is multimodal. Gemini 1.5 and different versions. Gamma is just text. Llama has different versions which are multimodal also. Claude is multimodal, and all those things. Falcon. So there are lots, Mixtral from Europe. Okay, so the beauty of all this research is, at the end, the idea is very simple, which is amazing, right? The good work, when you understand, read it, at the end, it's so simple, so natural. You say, well, I could have come up with, but you didn't. Somebody else did it, right? So the GPT, generative pre-trained transformer, idea is very simple. Predict the next word, okay? So which means you have a text. So you start with the beginning of sentence. Life is a work in a progress. So each is a word. Life is each word. And you put this in a learning model, the transformer. Then you want to predict the next word. But you already know because you are training, right? You have the whole sentence. So, you put the next word and you train this. There are a lot of text. Keep going. And then it can do very interesting things. So it is self-supervised, which means most of the new AI models are supervised, that you have to annotate, and that requires a lot of human labor, is expensive, right? So suppose you want to recognize, say, airplanes, or you want to recognize bicycles. So that's where the whole research started from ImagineNet, right? ImagineNet 1,000 classes, and 10 years ago, maybe 12 years ago, these Feifei Li and her group, they collected these lots of images for each of the class and annotated, and they trained the deep learning model, and it worked very well, right? That's why after that, people started taking neural network very seriously. Otherwise, the neural network, when I was a graduate student, neural network used to be a dirty word. Say, well, we don't want to do that because we don't understand how it works, and it was slow, it was problems. The reason was we didn't have the fast computers, and we did not have the data. And they show that that if you have the data and you have the computing power, then you can really do very well. Okay? So that was supervised. First phase of the deep learning was supervised. But now you can do self-supervised, that you don't need annotation. As I told you, if you have text, you have the input text, you have the output text also, right? So you just predict the next word. So whatever it predicts, you minimize the error. It will predict junk, but you minimize the error, you learn, and will start predicting the right word. Okay? So it's what is called autoregressive, which means you will predict the word, then you bring it back, and you send that also. Okay? You keep doing that, and that is what's happening. And it's a unidirectional because it's a sequence. Okay? So it's a causal. It hasn't seen it will not, you're not going to use the next words. It will predict the next word. So it will somehow figure it out, the relationship between various words in a given context. Now, what's the limitation of the LLM? They are large. They are black box. It just works, but we don't know why it's working, and that's a problem. Because if you're going to use this in the real world, people need to know, if there are regulation and all this thing, people need to have evidence, why it's working. So they have bias, and that's what we're going to, focus on the second part of the course. They have hallucination. Many times it will give you right answer, but sometimes it will make up things, because that's the way it got so much, billions of these words. And there are lots of IP issues, because if you are using somebody else books, like New York Times is a lawsuit, right, on OpenAI, that they use all their stories and and was actually just repeating. It's called memorization. So it will just repeat the whole article. And so the thing is, people got excited. That's amazing. We never thought it will work like that. Now, there are two things. One is that there's lots of application, lot of innovation you can do here. You can do this one. You can do this, which is good. At the same time, then it's not perfect. There are lots of things we can work on and needs to be solved. Okay, so application of LLM is you can generate a code. You don't have to write your code yourself. It will give you a code. That's why, this one of the guy, computer scientists say, that we don't have to teach programming in computer science, courses, because it's not necessary. You can generate content, you can do copywriting, conversation tool, education tools. The biggest impact of AI will be on healthcare and education, because it's going to change what we teach and how we teach. Okay? This is big disruption. Enterprise search, information retrieval, and all those things. Now, this was about text only. Now, the visual language model. So there we need to actually bring in vision capability. And they are fundamental because all the navigation, the self-driving cars, and healthcare, the MRI, biomedical imaging, all those things you need, other sensors, right? And humans are good in communication through language, and we want to find out the relationship between objects and their location can better describe the language. So these models bridge the gap between vision and language, and they understand both image and text. Then we can output of VLM can be modified through human provided prompts. And suppose you can do segmentation given an image, you can segment, but you want to segment particular part of the image, like a bounding box. So you can interact with the system and you can ask questions and so on. And you can do robot programming, because this used to be very hard to program robots, right? So now you can use the language and the vision to program robots very easily. It'll come up with the instruction how to, program the robot. So the humans are only species which learn the language, right? They can gather knowledge symbolically through language. And so, and we have 5 senses. So we have vision, hearing, touch, taste, and smell. And language is, not enough. We are using all those to survive. So now large multimodal model, LMM, can be image, video, text, audio, like physiological signals, the heart rate, and all those things, and so on. So now the one of the first visual language model you can say was what is called CLIP. The OpenAI has done lots of breakthrough technologies. So, like you guys know, the DALL-E, the diffusion model for image generation, was OpenAI, and CLIP was also OpenAI. And CLIP is contrastive learning, image pre-training. And again, the idea is very simple. So what you do, you look at the input image and the corresponding text. But there are lots of images and text on the web, right? People put images, they put a caption. So you learn the representation of an image, feature vector. So it will represent by one vector. And you also learn representation of the text, okay? So now you have this pair. This is an image of a dog. It's a dog lying in grass. So this is a positive pair. So, so you want to learn the representation so that this positive pair, the similarities between HI and HT is maximized. So we want to map these two representations in the same semantic space, okay? So input image representation will be a vector, and text be another vector in the same space. And they want to come closer because it's positive pair, okay? So this is a dot product and divided by the magnitude. You want to maximize that. Because whenever you want to learn, you have objective function, right? So this is the objective function. Now, the other pair, this is an image of an airplane, and caption is a dog lying in grass. It's a negative. So you want to take these representations, image representation, HI, and text representation, you want to minimize. You want to set them apart. Very simple. That's it, you know. So that's clip. So you learn using this, and it's amazing. So now once you do that, you can do lots of interesting things. So let's say you want to do image classification. So you have certain classes like ImageNet, 1,000 classes. You have an image, you want to recognize which class it is. So you take each class and get its text representation, and you particular image, you get its image representation, and you just match whichever is closest to, and this may be closer to this one, and you say this is the image of the dog. And that's it. No supervision, zero shot. Zero shot means that you don't need any examples. You have learned this. Okay? So that's what was the clip. And GPT-4 from OpenAI. Now in this one, there's no language model. It's very simple, right? So this is just a encoding of the text and simple, BERT and so on, but it's not a large language model. But the GPT has a full large language model, and that's the thing. And once you have then you can have all kinds of these conversation. Say, what is funny about this image? Describe it panel by panel. So there are 3 panels and give you these answers. Again, this is, actually old, year old, maybe more than that. So another example, mini GPT, describe the image and give the whole thing. The image shows a cactus plant standing in the middle of frozen lake. The cactus surrounded by the large ice crystal that have formed on the surface of the water. In the background, there is a range of mountains with snow-capped peaks. The sky is clear, blue with a few fluffy clouds floating in the distance. The overall mood of the image is peaceful and serene, with cactus standing tall and proud in the center of the frozen lake. So then say, is this image common in the real world? No, this image is not common in the real world. While it's possible for cacti to grow the cold climate, it's rare to see one standing in the middle of frozen lake. Additionally, the formation of large ice crystal surface of the water is also not common. Again, this image is like digital creation or manipulation. So all this using the knowledge it has from the large language models, all these, Wikipedia, all these things, and combining with what is C vision, which is amazing. So Lava is the most famous, one of the first one, the VLM, Visual Language Model, and this can also do what's unusual about this image and go through whole description. Okay. This is, anybody knows, they have seen this picture movie? How many people have seen this? Raise your hands. Oh, there's quite a few. Okay, it's an old movie. So you can do this. So now all these were for the images. Now you can do video sequence of frames. So you show these video and then ask question, why is this video funny? The video is funny because it shows a baby girl who's learning to read. She's sitting on the bed and looking at a book, and she's trying to read it the baby girl is wearing glasses, and she's holding the book with both hands. The big girl is trying to read the book, and her actions are adorable, endearing. The video captures the innocence and curiosity of a young child as she learns to read, which is a joyful, amusing sight for the visual. So, what is this video about? And generate a creative advertisement feature about this product that can be used on the product website. So see, instead of hiring people to do this video ChatGPT give you, and this is the commercial you can use for that. Now, the problem is that some people are concerned that AI will have impact, people lose jobs, right? Because these people who used to do this, now machine can do it. But this always happened, right? New technology. When the computers came first, people used to do, hand calculation, right? Slide rules and so on. So now computers are there, and people learn new techniques and get trained, and it's going to happen. So things like that, okay? So this is a paper I am also involved. Now, video ChatGPT was just text in, video in, and the prompt text in, and the output's text. Now here, we can do more than that. We can do actually segmentation, we can put a bounding box and so on. So then again, given a video, describe this video, and we'll go through that. Then some more questions about this. But this is interesting, right? What do you see in this video? So in this video, we see graph, and we put a bounding box on the graph, right? Standing on diving board, then jumping into water, put a bounding box into water, and so on. So which is more interesting? What do you see in this video? This is large stage of woman holding a torch in the right hand. So, but you put a bounding box on this and put, what that object is. So, which is interesting. Now, in this one, you can also put the audio. Okay, so we started with image, then video. Now we can put audio also. So, you guys know about this guy is Alex Friedman. It's a very nice podcast, very nice interviews he does. He was the MIT professor, but he quit. He can make more money, being a podcaster, YouTube. So, and this guy also. Everybody knows Steve Altman, the CEO of the OpenAI. So he was fired for a couple of weeks, and when Hinton received Nobel Prize, and they interviewed him. So this guy Ilya was Hinton's student, because this whole revolution is from Hinton, right? So Ilya was the one who fired this Steve Altman. So actually Hinton, when they were interviewing Hinton after winning Nobel Prize, so he was talking about different things and collaboration and so on. He mentioned Ilya. He said Ilya is the one who fired Steve Altman. So now the main thing here is that so if you don't put with audio, so it'll ask you based on the video, can you suggest a title for this video based on what you see and hear? So it said, based on this, I would suggest the future of technology and communication as a title for the video clip. But when you put audio, then it goes to the point, right? It's about GPT-4, ChatGPT, and so on. So that's, I think, that you want to use all the modalities which are available. Okay? So I think I'm going to stop here and continue on Wednesday, rest of it. And yeah, go ahead.
In the previous example, so I know that there's research going on where
Yeah. Okay, that's very good question. So see, most of these things started with English, right? The English language. So then there's a lot of work in China. Actually, China is leading this revolution. So there are whole large language model in Chinese. There are these large language models with multiple languages, right? So you could do all these different languages and whisper the model from, again, OpenAI, which will take the speech recognition. And then there is the Google Translate model, which will take one language, translate others. So that's another exciting area. Actually, this guy, Ashmal, he has a paper, 100 languages. So he has a paper on arXiv. You can look at that. So he has used 100 different languages. So you have an image, only image, or video also. Image, and you can ask questions in different languages and answer. But see, the science is that once you can solve the problem, language, right? Language is words, Chinese, English, French, same thing. You have tokens, you put in transformer, give you output, right? So that will be the the thing that it's not only for Western world, it is for the all. And what's the title of your paper? All languages matter. So you should be happy about that. Okay, so we'll stop here, then see you on Wednesday.